Hello everyone, my name is Zhe Weiling. I'm from National Chengkong University Department of Biomedical Engineering. The theme of this video today is to discuss with everyone that in the field of medical, how artificial intelligence becomes augmented intelligence, and how to transfer to assist medical personnel do more and more accurate and effective medical behaviors. First of all, I want to start with the very popular topic, coronavirus. From the end of 2019 till now in 2020, I think human society has made very big changes. These changes are due to the great impact of coronavirus on the world. Review the past decades. Last time, human beings have obviously suffered from this new type of pneumonia disease or SARS in 2003. From my perspective, facing two diseases in the world after 17 years, especially this new type of unknown disease, the attitude and the action we can respond to have changed a lot. One of the very important factors is that compared with the previous SARS, we have more artificial intelligence during this time of the coronavirus. Whether the artificial intelligence are tools or algorithms, they all can help humans fight the epidemic together. So today, I will start with how to use artificial intelligence to improve the prevention and treatment of COVID-19. First of all, we can see from the slides that the number of confirmed cases of coronavirus in each country since the beginning of January until March. In this coronavirus epidemic, many countries have generally inputted a lot of artificial intelligence tools in epidemic prevention, statistics, and even analyze the path of disease spread. Therefore, we can see that epidemics of coronavirus in every country can be updated in real time every day.
It can enable health centers to provide more information on the management, prevention of coronavirus, and the movement of the people, so the more effective management can be achieved. In the coronavirus epidemic, what can AI help us? In fact, we can see from some examples that have been used so far. In the genetic analysis of the virus, the management of the patient's symptoms, and the control of the crowds. Actually, artificial intelligence can bring us a very effective and very cheap tool to manage the coronavirus epidemic.
First, we can see that in places with dense crowds, such as airports and stations, there are currently many thermal image cameras placed in places where people flows are large. Via this setting combined with back-end artificial intelligence algorithm, it can find out those who have relatively high temperatures, whether they have the fever because of the coronavirus or not. Through analyzing the data of high temperatures of thermal imaging camera, they can find out and record those who have relative high temperatures. It is one tool that we use to monitor the spread of COVID-19. In this page, we use another way to show how thermal image camera matches the traditional CMOS camera to locate the person who may be suffering from the disease more accurately. When the signals in the thermal image camera and the image seen in CMOS camera can be compared synchronously, we can more surely know which one among the people have the fever and accurately record his or her face, photo, and time of entry. In this epidemic of COVID-19, the outstanding ability of artificial intelligence, especially in data mining, helped countries around the world better grasp the evolution of virus, as shown on this page. In the duration of this epidemic, in March, some researchers began to propose forward research. They found that although COVID-19 has more information seems to be spread from person to person in 2019, start from Wuhan, China. However, the genes of COVID-19 have actually experienced regional changes in three major geographic locations of China, America, and Europe. Therefore, the two combined with artificial intelligence and genetic analysis can make scientists and epidemic prevention researchers know more clearly that genes and the evolutionary path of this virus. It can provide political officials and epidemic prevention workers more information about decision-making in the production of vaccines or the path of the virus dissemination. In Taiwan, especially in NCKU, the prevention and the treatment of COVID-19 through artificial intelligence and numerous tools have been done quite well. In this page, we have intercepted some news clips which were filmed at NCKU Hospital by the news channel. We can see that NCKU Hospital has inputted the concept of so-called scientific and technological intelligence to prevent epidemics at that time.
For example, record the patient's data through the PET, including the travel history or symptoms that are provided by themselves. Then do more analysis by computer to compare whether the patient belongs to the high-risk group or the low-risk group of the COVID-19. Moreover, doctors can give more precise follow-up treatment to them through other pathological examinations or medical image examinations.
Artificial intelligence has a very important function in data mining. In fact, during the epidemic of COVID-19, many researchers have made a lot of predictions about how COVID-19 may break up and how many people might be affected. Therefore, at the time of COVID-19 outbreak, some artificial intelligence tools can be used to let everyone know the location and the time, and all epidemic prevention workers can react as soon as possible. Next, we will introduce to you a few key points of artificial intelligence in medical applications. One of them is medical image analysis. The scope of medical images is very wide, such as commonly used X-rays, computed tomography, and the nuclear magnetic resonance. They are all part of medical imaging. In terms of medical imaging, we can see that artificial intelligence can greatly help our pathologists or medical personnel who can interpret medical images. For example, artificial intelligence can help to mark these repetitive and obvious features first. Then the medical personnel can do the next stage of review, and finally get the results. This way can save a lot of medical manpower and that the mental state of these medical personnel to keep in state of death fatigue. On the other hand, traditionally, such as the pathologic images, these pathological slice images under the electron microscope or a traditional microscope actually requires a very large amount of professional manpower and a very long time to looking for possible symptoms or disease cells in the massive image data. Under such a long-term work, in fact, quite a lot of pathologists, their eyes or their mental state are under great pressure. So they are very forward-looking medical artificial intelligence companies in Taiwan, such as Ether AI Company Limited. They apply a lot of artificial intelligence to the interpretation of pathological imaging. These are some good examples of artificial intelligence that can help pathological imaging or medical imaging for assistance and analysis. Secondly, is the biomedical signal analysis. The biomedical signal generally refers to the various physiological signals that we can collect on the human body. Whether it is the electrical signal, a pressure signal, or the sound signal, both can be part of the biomedical signal. Today, we are going to show you a device called the AC Safe that developed by our lab. It is an AI-based screening equipment of arrhythmia and structural heart disease. In this screening system, we have already implemented the experiments of senior cardiologists into an edge computing system with deep learning model. Next, I will give you the brief introduction to the research we have done. First of all, the unmet need of this problem is to complete an image analysis system based on embedded system and deep learning method that can recognize arrhythmia and structural heart diseases using rest radical artery vibration energy. In my opinion, heart disease or cardiovascular disease is a very important issue in the world, so this device has its clinical utility. We can divide the cardiovascular disease into three categories, such as arrhythmia, structural heart disease, and coronary artery disease. In the study, we mainly conduct the analysis and the screening for the arrhythmia and the structural heart disease. With our device, we can measure the radial artery pressure wave on the rest of any person with different hand types. The below figures of this slide is showing the electrocardiogram of the certain subject, and the figure above is the pressure wave of the subject's wrist radial artery. We can see that when the heart contracts, we take the R waves as the time period of the heart contraction. We can observe that the pressure wave on the rest will be slightly later than the R wave in the ECG. And the time interval between these two waves is the time for our blood to transmit from the heart to the rest radial artery. We will introduce to you a system developed in our laboratory called the AC-Safe, which is based on the rest radial artery pressure wave to recognize whether the subject has an arrhythmia and a structural heart disease. Next, two students from our laboratory will demo it. First of all, one of the students has carried our sensor on his hand. Next, we click on the signal collection and recording on the user interface. The collection and recording time is about 15 seconds. After collecting and recording data, we display the waveform on the user interface, and then our operators will confirm the signal quality. Then, we will start our deep learning model on the embedded system. This is a set of algorithm model jointly developed with the NCKU hospital. It can classify whether the subject has arrhythmia or structural heart disease based on the radial artery pressure wave of the rest. After analysis is complete, our results will be displayed on the screen of the user interface, and the subject can finally see the results. Our subject today is the healthy college student who does not have any heart disease. So we can see the results of the analysis. The shown condition is so-called sinus rhythm, which is mean normal heart rhythm. By using this system, we transfer the experience and the wisdom of the cardiologist into artificial intelligence-based machine. In the future, the set of machine with the ported algorithm model can be promoted to more places, which makes different people use the wisdom of cardiologists. In today's lesson, the main message we hope to bring to you is that in 2020, we had a great change in our world caused by the COVID-19. That is, we can make a quick response to novel diseases such as COVID-19 by combining artificial intelligence and medical. The detection of physiological signals for screening patients who may be suffering from disease that we mentioned in the beginning. The analysis of the gene sequence of virus, which can observe its track of change. And the last is our self-developed rest radial artery pressure wave analysis device from NCKU. All we mentioned above are practical examples of using artificial intelligence to solve our difficulties in medical treatment. All in all, through today's video, we hope everyone can know that artificial intelligence not only promotes technology in industry, but also improves medical treatment. We can use artificial intelligence to help in medical field and assist medical personnel to make faster and better decisions. Thank you for listening.